All right, let's go ahead and finish the test 2 review guide. We are almost done. That'll be fun on the video. All right. Yeah. Stretch. Okay, stretching. All right, so we finished up Friday with the distance and midpoint. And at this point, what we've got is all what we've been doing most recently. So it should be pretty familiar to you. So if you're given a pair of points or two ordered pairs, then you can use those to find your distance and your midpoint with the formula that we're given for those. So first part, as long as my pen works, I always label my x1, y1, x2, y2. So x1 is 4, y1 is 5, x2 is 9, and y2 is -7. So my distance formula, let's see, do this without messing it up as I go. The distance equals the square root of the change in x, so x2, which is 9, minus x1, which is 4, squared, plus the difference in y, which is -7 minus 5 squared. And then we just simplify. So simplify inside your parentheses first. So this is just regular order of operation. Keep the parentheses until you know whether it's negative or positive, or eliminate the parentheses, but also eliminate any negatives, because we know that anything, even a negative number times itself, just the meaning of squared, is going to be positive. Everybody see that okay? All right, so 9 minus 4 gives us 5, positive 5 squared. -7 minus 5, this is like, but they're both negative. So this is -7 plus a -5. So we have a -12 squared. All right, so we know that 5 squared is what? 25. Remember, squared is number times itself, not times 2. So this is 25 plus 144. And we get a distance of 169. Now, if you have memorized your perfect squares past 12, 12 times 12 is 144. 13 times 13 is 169. And 14 times 14, I think, is 196. 15 times 15 is 225. That's usually about as far as I go. But we do know that this is the square root of 13 squared, and those cancel each other out. So the distance is 13. Wait, hold on, just 13. There we go. All right, and then midpoint, use your same x and y. Let's see here. It's just like super messy. Took up too much room Friday. Okay. Anybody remember the midpoint formula? All right, yep. It's just the average of your x's and y's. So remember, a midpoint is a ordered pair. So you're calculating an x and you're calculating a y. So it's the average of the x's as the x coordinate of the midpoint and the average of the y's as the y coordinate of the midpoint. All right, so we can just go ahead and plug that in and solve it. So x1 is 4 plus x2, which is 9 over 2. Y1 is 5. Y2 is -7 divided by 2. So your midpoint is at 4 plus 9, which is what, 13? Well, that's not very nice. That's right. This one has a neat distance, but a messy midpoint. All right, 13 over 2. And then 5 plus -7 is -2 over 2. So our final midpoint is 13/2 for the x coordinate and -1 for the y. You could convert it to a mixed number, sure. That would certainly help when you're graphing a coordinate. So when you're graphing a point on the Cartesian plane, to me, it is easier to convert your midpoint. So that would be what, 16 and 6.5? Because then you know that the x coordinate is going to fall between 6 and 7 when you graph it, but we don't have to graph these. Okay, any questions on distance and midpoint? I think everybody did pretty well on that quiz, so we should, I mean, beyond the careless errors, right? I think, oops, hello. Because what's 2 divided by 2? So please simplify that. So that's why it's -1. All right, so we have this again. We want a standard form equation of the perpendicular bisector of our line segment AB, where A is at the ordered pair -5, 4, B is at the ordered pair -1, -2. All right, so I like to have a, let's see, so -5, 4. So this line, I like to have some sort of visual aid. So let's say this is A and B. And then we want an equation for the perpendicular bisector. So what do we know about a perpendicular bisector? Its slope is the opposite reciprocal. So we got to find the slope of AB. And once we do, we can find the slope of our perpendicular bisector. And what else do we know about a perpendicular bisector? Which means? No. Well, the 90 degrees applies to the slope. So we've already confirmed that. We know that a bisector. In the midpoint. Yes, so it intersects our original line segment at the midpoint. So if we calculate the midpoint of line segment AB, we can then we know the slope of the bisector, and we know a point that exists on the bisector because it's going to go through the midpoint. So like we did when we reviewed for our last quiz, and on the last quiz, we need to calculate the slope of our current line and the midpoint of our current line segment AB. Once we do that, we can then create an equation for the perpendicular bisector. So let's do slope first. So I'm going to do x1 is equal to -5, y1 is equal to 4, x2 is equal to -1, and y2 is equal to -2. So I'm going to use this to first calculate the slope of line segment AB. And what's our slope equation? Rise over run. So rise involves our y's. So the difference in y, so y2 minus y1, so this is -2 minus a -1 over the run, which is the x, difference in x. So this is x2, -1, minus x1, -5, right? Did I do that? I did not do that right. I don't think I did. Hold on. Let me just write the equation. Y2 minus y1 over x2 minus x1. I think yes, because it's so easy to do. I don't know why my brain really struggles with that. Okay, so y2 is -2 minus y1, which is 4. There we go. That's better. X2 is -1 minus x1, which is -5. All right, so I'm going to keep going here. So I have -2 minus 4. So this is -2 plus a -4. So -6 over -1 plus 5, which is the same thing as 5 minus 1. So that's a +4. All right, so we simplify that to -3/2, right? These both divide by 2. Which is, okay, because it's slope, I'm keeping it as an improper fraction. I see what you said. Okay, I was thinking numerator, denominator. All right, so this is -3/2. So the slope, let's change color so it's visible. The slope of the AB, our original line segment, is -3/2, which means that the slope of our perpendicular bisector is what? Is what? +2/3. Yes. Everybody good on where that came from? Opposite reciprocal. Change the sign and just flip. That's why I keep it as a fraction. Flip the fraction. Okay, so now we have the slope of our perpendicular bisector. So now we need to know the midpoint so that we can calculate the x, y, and or the a, b, and c of standard form, or the y-intercept. Okay, so the midpoint of AB, we still have our x1, y1, x2, y2. So midpoint is the average of the x. Here I go again. X1 is -5 plus x2, which is -1 divided by 2. Comma in there, so you remember that you've got an ordered pair here. So y1 is 4 plus y2, which is -2 divided by 2. All right, so -5 plus -1 is -6 divided by 2. 4 minus 2 is 2/2. At least the midpoint's neat, right? Check my math, guys. So our midpoint falls at -3/1. 4 plus, yep. Okay. So what formula do y'all want to use since we're writing this in standard form? Okay. Why don't we use point slope?
Oh, use point slope. Okay, you asked me.
I know.
And then you were like, no.
Well, there was a better answer. Well, we don't have a lot of room. So because how do they want us to write this? They want us to write this in standard form. And the point slope, we can go either in standard form by moving the x over to the y side, or we can, like, you can go in either direction. Okay. All right, so what do we need to write in our point slope equation to get the standard form? What do we have that we can put in there? Our slope and our point. All right, can anybody tell me my point slope formula? Y minus y1 equals m, which is slope, times x minus x1. There is our point slope form. And remember, you're going to end up with the x and the y, not the x1 and y1, but the x and the y will stay variables in your final equation. Because this is the equation that represents the entire graph. So it represents the infinite number of ordered pairs, x and y. All right, so now would anyone like to tell me what my equation looks like after I plug in my points and my slope?
Yes,
You got me? Okay. Y minus. What point are we using?
My fault. Y minus 1.
There we go. Yeah, let's don't forget, use your midpoint. Nope, that's okay. The other ones don't exist on the perpendicular bisector. So y minus 1 equals,
2/3
yep,
x minus negative.
right. Right, which we can simplify to x plus 3. I'll do that as I distribute. Who would like to distribute? Who always misses distributing on the exam? I got a few of y'all. Should I have? I don't. Do you miss it? You don't miss it much. Gabe, what do I need to distribute? Come on. You are not the only one. So most of this class definitely would need to keep their mouth shut. So what am I distributing? Right. So I'm gonna just go ahead and bring down my y minus 1, and 2/3 times x is 2/3 x. Yep, that does not change. All right. And right, that times the minus a negative 3. But we also know that anytime we subtract a negative number, that's the same as what? Anybody? Addition. Thank you. All right. So this is, how would you do 2/3 times 3, Gabe?
Would it be 6/3?
It would be 6/3. Yes, we take our numerator 2, multiply it times our whole number 3, but then divide by 3. And what is 6/3?
2.
Yes.
And you're
Stressing. All right. Okay. Now what do I do? Can I go? Let's go ahead and combine our constants, the -1 and the +2. So we know the constant is going to end up being our c in a standard form. So I'm going to just move it to the right side. So I have y equals 2/3 x plus 3. Okay, so here's the thing about the standard form. You need to get rid of your fraction. What would we do here to get rid of that fraction, that 2/3? Y'all remember this? Multiply every term times 3. So when we do that, let me change colors just so it's a little bit visible. So this is 3. Well, hold on. So 3 times y. What's my next term? 2/3 x. So 3 times 2/3 x. And then my last term is my constant term. So that's 3 times 3. And I know the way that I've placed it looks really bad, but this is just 3 times 2/3 x. And those cancel out. And so we're left with 3y equals 2x plus 9. And you can get rid of that 2/3 at any point. We could have done that with when we were at this stage as well. But I like to simplify it as much as possible so that there's fewer terms that I have to remember to multiply my 3 times.
So why did we multiply?
To get rid of that fraction.
Could we get that fraction and count it?
You could. The problem is you're not going to have the correct A, B, and C. In standard form, we don't, because you wouldn't know that 3 is your B. Because once we do this, we subtract the 2x from both sides. Sorry, I got to write it over here. So we end up with -2x plus 3y equals 9. And that is our standard form. Now, the nice thing is if they want you to write it in slope-intercept form, once we had it at y equals 2/3 x plus 3, we would be done. Because when we have the slope, when we have point slope form, all we need to have is the slope, which often is a fraction, 2/3, and then our y-intercept, which is 3. Because you have to isolate your variable y. We would not keep the 3 multiplied times the y. In standard form, you do get rid of the fraction because then it gives you your b. It gives you your coefficient of y. All right, so that's it. We will start the test tomorrow. So is there anything on this review guide that looking back, you are really not sure what you wrote or what you have, or you want to review it anymore? Now would be the time to do it.